What in the world is a BTU? Welcome back to the DIY Off-Grid channel, guys, the podcast where we go over all things related to the world of living off-grid. And today we'll be continuing on with our coverage on topics associated with energy. I use the word BTU all the time on our live stream discussions, and it's easy to get carried away talking about it when there are plenty amongst us that don't really know what it means. So let's unpack this term that is so central to our understanding of energy consumption, especially in the context of heating and cooling. The BTU, or British Thermal Unit. Let's start with the definition of BTU. Those three letters stand for British Thermal Unit, and it is specifically the amount of energy required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. It's a bit of an oddball in the context of units of measurement because, well, pound and Fahrenheit, they're not metric units. It originated from the British, who came up with the avoirdupois pound that originally came about in England around the 13th century, and the Fahrenheit scale for measuring temperature, which was proposed by none other than Daniel Gabriel Fahrenheit in 1724 to the Royal Society, who, interestingly enough, was a German person born in Poland. Without going too deeply into the history of the Fahrenheit scale, which we can definitely cover some other time here, during the Industrial Revolution, a means of measuring thermal energy was necessitated by heating water up to produce steam, which became the backbone of powering machinery during the time. And that's where they settled on the British Thermal Unit, a thoroughly British invention with the use of imperial units. For us Americans who still use pounds and the Fahrenheit scale, it's quite unambiguous to use the BTU. Even a child that can comprehend weight in pounds and the temperature reading from a thermometer can easily understand and grasp the concept, quite unlike kilowatt hour, which we discussed yesterday. Now that we know what a BTU is, how is it utilized in more practical everyday scenarios? Let's go over some examples. A typical gas range has a burner that puts out somewhere between 500 to 15,000 BTUs per hour. On full blast, 15,000 BTUs would equal raising the temperature of 15,000 pounds of water by 1 degree Fahrenheit. Or for each second, 15,000 BTUs per hour is just 4.17 BTUs per second, of which half a gallon of water happens to weigh 4.17 pounds. Meaning each second that burner is on, it would raise the temperature of half a gallon of water by 1 degree Fahrenheit. If that tap water was 62 degrees Fahrenheit, after about 2 minutes, that half a gallon of water would hit 182 degrees. In 30 more seconds, it would hit the boiling temperature of water, at which point it takes another 970 BTUs to convert 1 pound of water into 1 pound of water vapor for the phase change of water to take place. Fortunately, we aren't producing steam in our homes these days for heating, so we can do some more of that mathing another day. Other applications of BTUs in America, we have another rather strange unit, a ton of refrigeration. Air conditioners will often be labeled by X number of tons. You might hear someone say, I have a 3-ton air conditioner. A ton of refrigeration is the amount of heat required to freeze or melt 1 short ton of pure ice at 32 degrees Fahrenheit in 24 hours. Prior to homes and businesses having access to refrigeration and air conditioning, there was actually a vast ice trade in the east coast of the United States where they would literally extract ice from cold climate areas, ship it across the country to its destination for use in refrigeration and air conditioning. As it was common for society to use ice in this manner, a ton of refrigeration became an intuitive unit of measure for people during the end of the 19th century, and the unit was formalized in 1903. The modern definition of 1 ton of refrigeration is 12,000 BTUs per hour, so that 3-ton air conditioner example earlier would have a 36,000 BTU rating. In addition to refrigeration, it is also used in the context of heating. Water heaters and furnaces in America are most commonly rated in BTUs. A natural gas based tank water heater might have a 30 to 40,000 BTU burner. Say if you have a 50-gallon water tank, 50 gallons of water is roughly 417 pounds of water. For the water temperature to go from 50 degrees Fahrenheit to 120 degrees, 417 times 70 yields 29,190. 29,190 BTUs would be needed to make that happen. With the 40,000 BTU burner, 29,190 divided by 40,000 equals 0.72975 multiplied by 60 equals roughly 44 minutes to heat up that fresh tank of water. These are simplistic calculations as there are a lot of additional factors to consider, notably the quality of tank insulation and how efficient the burner is at capturing the heat and transferring it into the actual water. But being armed with these formulas, now you can estimate how many BTUs you need if you use one tank of water every day for a month. Multiply that 29,190 with 30 and you get close to 900,000 BTUs for water heating needs. For those of you who use propane for heating, 1 gallon of propane contains roughly 91,500 BTUs. In that above example, you would use roughly 10 gallons of propane per month to heat up your water. Propane is most commonly delivered in gallons, so that conversion is fairly easy to make. It does get a little trickier with natural gas as utility companies use several different units of measure to distribute natural gas to residential customers. The most common units for utility companies are CCF, or a volume of 100 cubic feet, MMBTU, or 1 million BTUs, or therms, which is 100,000 BTUs, or a tenth of a MMBTU. Now, 1 CCF is equivalent to 103,800 BTUs. So based on these units, you can figure out how many BTUs of natural gas you use from your monthly utility bill. Some other conversion factors: 1 kilowatt hour of energy, the unit of measure we discussed yesterday, is equivalent to 3,412 BTUs. A pound of good quality anthracite coal contains about 13,000 BTUs. A gallon of gasoline, roughly 120,000 BTUs. A gallon of diesel or heating oil, for those of you in the Northeast, is roughly 138,000 BTUs. Propane, as pointed out earlier, is roughly 91,500 BTUs per gallon. 1 quart of firewood can vary from as little as 12 million BTUs to over 30 million BTUs depending on the species and moisture content of the wood. And just for the sake of comparison, 1 pound of uranium-235 undergoing complete fission would yield 37 billion BTUs. That gives you an idea of how energy dense fuels are in the context of nuclear fission. So the next time you turn on your stove or run the hot water on your tap or turn up that thermostat, think about that simple unit of measure, the BTU, or British Thermal Unit. So simple a child can understand the amount of energy to heat up 1 pound of water by 1 degree Fahrenheit. And one of those relics of the British units of measure that won't go away in 2024, of all places here in America. Rather odd because even the British have formally adopted the metric system themselves. But thanks to the influence of American companies, pioneers such as York, Carrier, Frigidaire, and General Electric, it's a unit that still holds influence not only in America but around the world in the context of heating and cooling. Just like horsepower for how powerful a car is and inches for how big your TV screen is, seems like BTUs are here to stay. Thanks for watching the DIY Off-Grid channel today, guys. I really hope that was every bit as interesting and insightful as can be for such a mundane elementary unit of measure. And of course, I hope you learned something new today. If you have any topics you'd like me to cover, as always, feel free to reach out to me. If you have any questions about solar and wind and batteries, or just looking to save on utility bills, sign up for that on my TikTok profile directly, or head over to allthingsoffgrid.com and sign up for the DIY battery sheet there. That's all for today, guys. Stay healthy and stay curious, my friends.